Hi, my name is Arpit. In this video, I will be demonstrating week 5 of our electronics lab. This lab is all about analog part, so we have to demonstrate the comparative analysis of BJT, MOSFET driven circuit with LED. So in this experiment, there are 4 parts, so I will be demonstrating each part one by one. This is my ID, and let's proceed with the experiment. So this is part 1 of the experiment 5 of analog, and let's start with this experiment. So as you see, this is the diagram of this experiment. So I have to connect these components accordingly and plot the graph of IC versus VEC. So let's start with this. So I am using a 1 kilo ohm resistor that is connected in a VCC, and another end is connected to the collector, and this green wire is connected to the ground, which is the BJT of emitter, and this is a 1 kilo ohm resistor connected with the base. So I have read the data sheet of this transistor. So the maximum voltage supplied to the base is 0.7 volt. So accordingly I choose this resistor, and I set to the voltage supply in the base. So first of all, I have to measure the VEC voltage, that is, so first red probe goes to the collector, and black probe goes to the emitter. So now I am giving the VCC power, that is a 5 volt, and the VEC of this is that is 0.72. In my document, as you can see, 0.67, so it's slightly differ, but yeah, that is VEC when I giving the 5 volt. And let's decrease the voltage to the 4.5, and I decrease the voltage, as you can see. When I decrease the voltage, as you can see, the VEC is 0.32. So as you can see in the VC voltages through collector and emitter, so that is 0.32 volt. So let's calculate the IEC of this VJT. And first of all, for the calculating of IC, I am measuring the voltage across this resistor, and as you can see, the voltage across this resistor is something around 4.23, and I divide the resistor value. I am using 1k resistor, that is 1000 ohm. So I divide by 1000, so it will give me something around 4.2 milliampere when I set the VCC is 4.5. And let's set to the VCC 4 volt, and see what is the, and I'm setting the VCC. Now we can see what is the voltage across this resistor. So that is 3.76, and if I divide by this value, so I'm getting something around divide, and the ampere I am getting, that is something around 3.76 milliampere. So that is the IC value. And measuring these values, I have as you can see, I have plotted the graph. This is VEB, that is fixed to, I am fixing to the 6.9, and VCC is, that is varying between 0.5 steps, and this is the graph, as you can see, of the VJT. This is part 1 of the experiment with the MOSFET. As you can see in the circuit, I just replace BJT with the MOSFET, and the circuit is same. So I am in this part, I am plotting the graph of ID versus VDS for the MOSFET. So let's see the circuit. I am using a 1 kilo ohm resistor that is connected with the drain, and this is ground connected with the source, and this is gate pin number 1 that is connected with the 1 kilo ohm resistor, that is trim pot, 10 kilo ohm trim pot, and this resistor is connected with pin number 2, and I'm giving a 5 volt this trim pot. So let's, and the VCC is also a 5 volt. So let's check the VDS value. So for checking the VDS, I'm connecting negative pin of the multimeter to the source, and positive pin probe connected to the drain. So as you can see, I'm giving a 4.4 volt VCC, and as you can see, the VDS is 3.58 volt. Let's decrease to the 3 and see what's happened. And as you can see, I am giving the VCC, that is 3 volt, and the VDS is 2.64. So, and let's check the ID of this MOSFET. So for checking the ID, I just I just measure the voltage across this resistor that is connected a connected load between VCC and the drain. So I'm measuring the voltage across this resistor, so I'm getting 0.33 and I'm divided by 1000 because this value, this resistor value is 1 kilo ohm. So yeah, so I'm getting the ampere ID, that is 0.33 milliampere. So yeah, and I'm reading the data sheet of this MOSFET. So for the gate, I can give from 2 volt to 4 volt, and yeah, 2 to 4 volt. So accordingly I choose this resistor value, and I taking the step of 0.5 to 0 to each 5 volt and making this graph. And as you can see, this is the MOSFET graph. So yeah, so this is the part 2 of this experiment. In this experiment, as you can see in the figure, this is a LED driven circuit using BJT. So first of all, let's see the circuit what I am using in this circuit. So this is 200 ohm resistor, this is LED, and this LED negative pin is connected to the collector, and this emitter is connected to the ground, and this base is connected to the 5 kilo ohm resistor that is goes to the 2 pin of the potentiometer. I'm using two 10 kilo ohm resistor, since I don't have 5 kilo ohm resistor, so I using a 10 kilo ohm resistor in parallel. So and I read about the BJT data sheet. So I'm giving 6.5 0.65 volt. I'm giving 0.65 volt in the base. See the behavior of VEC. So now I'm giving the VCC, that is 0 volt, and as you can see the LED is not glowing. So now in the now the BJT is not activated. So let's give the 0.5 volt, and as you can see now same BJT is not in active mode. So let's give the 1 volt and see what's happened. And as you can see, when I'm giving 1 volt, BJT is same in condition. I'm giving 2 volt, and as you can see the LED is slightly glowing. And if I giving a 4 volt, LED is glowing more brighter. So this is the switch, this is working like a switch. So and the another thing is, when I adjust this base current, and as you can see, when I adjust this base current to the 0, now as you can see I am adjust the base current to the 0 and the LED is not glowing. If I increasing a little bit of the base current, LED is slightly glowing. When I increase the base current, let's connect the multimeter to the base and see what's the voltage. Now as you can see, that is 0.59 and LED is glowing. Now if I decrease to, now if I giving 0.45, LED is not glowing. If I am giving 0.5, now the LEDs started glowing. So this BJT is clearly shows that it's when I increase the base current, so the emitter and collector flow is increased. So that is the part 2 of the experiment. This is the part 3 of this experiment, that is a MOSFET transistor driven circuit. So as you can see in the figure, that is same, just I replace BJT with the MOSFET. And yeah, so in this experiment I have gradually increased the voltage, output voltage, and observed the brightness of the LED. So I'm using a 200 ohm resistor that is connected with the positive pin of the LED, and this negative pin of the LED is connected with the drain of the MOSFET, and this green wire is connected to the source pin of the MOSFET, and this 1 kilo ohm resistor connected with the gate, and here it is connected pin 2 of the trim pot, and I'm giving a 5 volt power supply. So now I'm giving a 0 volt VCC. So let's set to the 1 volt of the VCC and see what's happened. As you can see, when I giving a 1 volt, now LED is not glowing, and I'm giving a 3 volt. As you can see, the LED is glowing. Now I'm giving a 5 volt. You can see the LED is glowing more brighter. So and I can dim the LED using this gate, how much voltage I am giving to the gate. So now what voltage I am getting in the gate, what see in the multimeter, I'm getting that is 4.92. So let's decrease the voltage of this. As you can see, I am decreasing the voltage of gate pin, and now you can see the voltage is 2.33, and the LED brightness is also decreasing. When I decrease more, as you can see, the LED is more dimmer. You can see when I go to the 0, the LED is little bit glowing, but not as much. So yeah, so this is MOSFET transistor driven circuit. So this is the part 4 of this experiment, and as you can see in the figure, this is the circuit of light dependent resistor control LED circuit. So I connected this circuit accordingly in the physical. So as you can see, I have to do when the voltage across LDR and the current through the LED when the LDR is exposed in the light and kept in the dark. So let's see the circuit. So this is a 100 kilo ohm resistor connected with the positive pin of this LED. This the negative pin of the LED is connected to the collector of the BJT, and this base is connected to the 200 ohm resistor, and this emitter is connected to the negative of this power supply. And this is 100 kilo ohm resistor connected with the VCC in the same pin of the base of the BJT, and this wire goes to the pin 1 of the LDR, and this pin 2 of the LDR goes to the negative. So as you can see now, current flow through the LDR, that is 0.03. when I turn off the light, and as you can see, when I turn off the light, the LED is glowing, and as you can see, the current flow through the LDR, that is 0. So let's turn on the light, and as you can see now, the current flow through the LDR, that is 0.03. So what happened in this and that time, as you can see, I connected a 100 kilo ohm resistor with this BJT base. So when the current flow through the LDR, negative current flow through the LDR and goes to the base, cut off the current flow through the emitter and collector. When the resistor, when the LDR is when the current flow through the LDR is 0, now some base voltage, that is 100 kilo ohm connected with the base voltage, flow through this, and this emitter and collector is on active mode and LED is glowing. So this is the behavior of this LDR. When I expose the light on this LDR, the current flow through this LDR increases, and when in the dark, the current flow through the LDR decreases to the 0. This is the experiment 5, and this is part 4. So thank you.